Hello friends, welcome to Maths Tutor channel, and this is part 4 of mathematical physics paper solution BSc 3rd SEM physics honors students. This is paper C5 of 2020, right? So in part 1, 2 and 3, in previous 3 parts we have solved from question number 1 to question number 3b. So in this video we're going to start from question number 3c. So let's start. And before we start, subscribe the channel if you are new to my channel, and also hit the bell icon so that you get notified when new video will be uploaded, and share with your friends, and hit the thumbs up button. So now let's start. So this is question number 3c. Here we need to prove these two, right? So how to prove the first one? So let me show you. So here, this symbols have their usual meanings. That means this Pn of x, this is Legendre polynomial. So hope you know these things. So now let me solve this one. Okay, so now you see. So solution, we know that the recurrence formula for the Legendre polynomial Pn of x is given by this relation. This is the recurrence formula for the Legendre polynomial Pn of x. Okay, so here to prove this first one, so to prove this one, n plus 1 Pn plus 1 of x twice n plus 1 x Pn of x minus n Pn of x, n Pn minus 1 of x. So in order to prove this one, just replace this n by n plus 1. Just replace n by n plus 1. So we get, after replacing n by n plus 1, we get this result, right? So here you have put n plus 1, n plus 1. So here also put n plus 1, here also n plus 1, right? So, and doing so, we have got this result, right? Now if you simplify this, then what you will get? So multiply these two and then subtract, then so at the end we have got this result, right? So this is what we need to prove. Okay, so hope you have understood this. Next relation we need to prove is this one. This is the next relation we needed to prove. So here we know that 1 minus 2xz plus z square whole square, to the power minus half is equal to summation z to the power n Pn of x. We know this relation. So if you differentiate this with respect to z, then you will get this result, right? So we have differentiated this above relation with respect to z, right? This minus half comes for here, and we have applied this formula ddx of x to the power n is equal to n into x to the power n minus 1. So here instead of x we have z, right? That's the difference only. So hope you know these things. So now this implies if you multiply this half with these two terms, minus half with these two terms, then what you will get? So you're gonna get this result, right? Suppose let it be equation number 1. Again, if you differentiate 1 with respect to x, now this time we are differentiating the equation number 1 with respect to x, and doing so what we have got? So again, this is function of function. That's why if you differentiate it again with respect to x, then here you will get minus 2hz, right? On the right hand side, this summation z to the power n will remain same as we are differentiating with respect to x. Then Pn of x on differentiating, it will be Pn this of x, right? So if you simplify this, what you're gonna get, so here this half, this two cancel, right? So that's what we have got, right? So now let me write these two results. Just let me take these two, equation number 2 and 3. Just let us take this is equation number 2 and 3. Okay, then what will happen? Now let us divide equation number 2 by equation number 3. Okay, so divide this equation by this, right? If you divide this, these two terms will be cancelled. So on the left hand side you will get x minus z by z, right? And on the right hand side, what you will get, so here let me show here. So you're gonna get this result, right? So that means if you divide these two, right? So just wait. Now if you multiply this z here, then what you will get, and this will be z to the power n, right? So after cross multiplication we get this result, right? Now you see, now let me write this result on the next slide. Okay, let me take a new slide. So this is the result we have got. Now here you see, if you expand summation z to the power n, then what you will get, z to the power n plus z to the power n minus 1. So let me rewrite the relation again with, so this is the relation we have got, right? So now you can write this, you can write this term as sum of x Pn dash of x z to the power n, then next term will be x Pn minus 1 dash of x z to the power n minus 1, plus so on dot dot dot, right? And the next term can be written as like this, right? Zn plus 1 Pn dash of x, next will be Zn Pn minus 1 dash of x, right? And plus dot dot dot, so on. Similarly, the right hand side, this part, the right hand side can be written as like this, plus dot dot dot, so on, right? Now equating the coefficients of z to the power n. Okay, coefficients of z to the power n, right? What you will get, so you will get this relation if you equate the coefficients of z to the power n only, right? So what we have got, so this is one term, and this is also a coefficient of z to the power n, and here we have got z to the power n, so this is the coefficient of z to the power n. So we have got this result, right? Equating the coefficients of z to the power n, that is what we have got, right? So you can write here, what you can write, equating the coefficients of z to the power n on both sides, on the both sides. So we have got this relation. So this can be written as this, right? So that is what we needed to prove. So hope you have understood this. So now let's move on to next question. Sorry for interruption. Just before we continue, please go to the community post and here, you may vote which subject you want me to create. Okay, I want to create a course on any one of these 4 subjects. So just vote which one you want. So now let's continue. So next we need to prove this Bessel's differential equation. We need to solve this Bessel's differential equation. So let me show you how to solve this. So this is the solution, not completed it. That will be completed in the next slide also. So this is the solution of the Bessel's differential equation. In this slide it is not completed. So in the next part of this, in the next slide. So in order to save time, I have taken the solution from the book directly. So here you can see this is the Bessel's equation, and we have considered its solution. The is given by this series summation of here you see AR x to the power m plus r, right? So which is given by a naught x to the power m, a1 x to the power m plus 1, and so on. So this is suppose equation number 2, and this one we have taken equation number 1, right? So now if you differentiate this equation number 2 with respect to x, then you will get this relation, right? And if you differentiate it again, that means if you find a second order differentiation of equation number 2, then you will get this result, right? I hope being a student of BSc, you know the differentiation well, and differentiation and integration, those things. Then if you substitute the values of dy by dx and dy by dx to in equation number 1, right? If you put the values of these two terms, if you put these two values in this equation number 1, in Bessel's differential equation, then what you will get? So you will get this result, right? So this term is replaced by this result, and this is replaced by this result, right? So hope you have understood this. We have substituted these values here in equation number 1, and we have got this result. And if you simplify this after simplification, so we have got this result, right? So once you get this result after simplification, now equating the coefficients of x to the power m to 0, we get, that means here you see this right hand side is 0, right? This right hand side of this equation is 0. You can consider this 0 as 0 into x to the power m. So if you equate the coefficients on the both side of this equation, 0 and coefficient of x to the power m, if you equate that x to the power m, so for x to the power m, in order to get x to the power m, this r should be 0, right? Here this r should be 0, right? So here also it will be 0, then you will get x to the power m, and so here it should be a 0, that means a naught, right? So we are getting this result equating the coefficient of x to the power m on both sides, right? So here you see, if you let me explain this again. So here we have x to the power m plus r, right? In order to get x to the power m, so this r must be 0. If r is 0, then this r also 0, and this, instead of a r, here we will get a naught or a 0, you can write. So, and equating the coefficient of x to the power m, so the coefficient of x to the power m on left hand side, it becomes a naught m plus 1 m plus 0 whole square minus n square, right? And on the right hand side, the coefficient of x to the power m is 0, so that's why equal to 0. Now this implies m square is equal to n square, that is m is equal to n. So if you see, so here a naught, this equation will give you this result, right? If you simplify this, you will get this. So now you see remember a is not equal to 0, a naught is not equal to 0. Okay, and now equating the coefficient of x to the power m plus 1, right? So in order to get m plus 1, how to equate the coefficients m plus 1? So now you see, so as we have on the right hand side 0, you can consider this one also 0 into x to the power m plus 1, right? And here you see this is x to the power m plus r. So in order to equate x to the power x to the power m plus 1, so you have to put r is equal to 1, right? If you have to put r is equal to 1, and putting r is equal to 1, you will get this result. If you get the coefficient on the left hand side, you will get this coefficient of x to the power m, you will get this, and on the right hand side the coefficient is 0, right? And so here you see, now as we have already got m is equal to n here, m is equal to n, so if you use this relation here, m is equal to n, then here this equation will implies this equation. From this equation, what you will get? From this equation you will get a1. So here you see this m can be replaced by n, right? M can be replaced by, so then it becomes m plus 1 becomes m plus 1 whole square becomes n plus 1 whole square, then minus n square. Now you see n plus 1 whole square cannot minus n square, so this cannot be equal to 0, right? It cannot be equal to 0, because here you see m is equal to n, we have got m is equal to n. If you put m is equal to n here, so n plus 1, it is obviously 1 more than n, right? So if you subtract these two, this cannot be equal to 0. So that is why what we can write, that is why we can write that m plus 1 whole square minus n square is not equal to 0. If they are not equal to 0, then from this equation we get a1 is equal to 0, because you see if you see this, now you see product of these two is equal to 0. It is possible when any one of these two or both of them are equal to 0. So here we have got that this part is not equal to 0, so the only possible chance is a1 is equal to 0. So that's what we have got. Now similarly equate the coefficient of x to the power m plus r plus 2, right? So here you see, you can consider the right hand side 0 can be considered as 0 into x to the power m plus r plus 2. So here on the right hand side we have got coefficient of this term is 0, and on the left hand side in order to get m plus r plus 2, just replace, so replace this x to the power m. If you replace this r by r plus 2, then here also this r should be also replaced by r plus 2, and this r should be also replaced by r plus 2. So hope you know these things. So let me clean this part a little bit, and equating the coefficients we have got this result, right? So which can be written as a r plus 2 is equal to this. Here we have ar, okay, this is ar. So now let's go to the next slide. Okay, let me go to the next slide. So now those terms a3, a5, a7 dot 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 will be equal to 0, since a1 is equal to 0. How we have got this step? To understand that, let me go to previous slide here. So from here you see, if you put here r is equal to 0, then you will get not r is equal to 0. Here you see, if you put r is equal to 1 here, then you will get a3, right? So that's going to be equal to minus 1 by m plus 1 plus 2 whole square, and this ar will be equal to a1, right? So now you see, so here we have got a1 is equal to 0, so a3, so this term is 0, so this 0 into anything is 0, so it will be 0. So So now if you find a5 means if you put r is equal to 2 here, if you put r is equal to, sorry, not 2, 3, if you put r is equal to 3 here, then what you will get, a5 is equal to minus 1 by m plus 3 plus 2 whole square a, here you will get a3, right? So a3, sorry, so you will get this result, minus 1 by m plus 3 plus 2 whole square a3. That's what you will get on putting r is equal to 3, right? So as we have got already a is equal to 3, so if you put here 0, then this term will be also 0. So that's how for r equal to 1, r equal to 3, r equal to 5, we will get these terms a3, a5, a7 is equal to dot 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 a1, so whole are equal to 0, right? These all terms becomes equal to 0. So that's how we have got this relation. So hope you have understood. Now if you put r is equal to 0, you're gonna get this term, then r is equal to 2, you're gonna get these two terms, get this term, and this is a2, you have got here a2. Now put this value of a2 here, and this is a2, right? So you will get this result, and so on you can find the remaining terms as well on substituting these values of coefficients in equation number 2. Where is the equation number 2? So this is the equation number 2, right? So let me clean this. So if you put these values here, a0, a1, a2, these values, then you will get this y is equal to this. So this is the solution of Bessel's differential equation, which also can be expressed as y is equal to a0 x to the power n summation from r is equal to 0 to infinity minus 1 to the power r x to the power twice r, right? X to the power twice r, 2 to the power twice r into r factorial n plus 1 into n plus 2 and dot 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 n plus r. So this is the required solution. So hope you have understood this. So remaining questions will be solved in the next video. So stay connected and subscribe the channel if you are new to my channel, and if you think my videos are helpful, so share with your friends and stay connected. Thank you for watching. See you in the next video.